Hello, my name is Labria Broomfield, and I am currently a junior majoring in electrical engineering from also Mississippi. And I am working on the SunFounder Smart Home Kit, or also known as the IoT Kit. So today, the first project we'll be working on is the photoresistor. So for the IoT Kit, it has a photoresistor, more so like this. I'm kind of used to just the two legs and a resistor. But this one has a photoresistor, and it has the resistor value, the actual resistor that you will use if it was just a photoresistor by itself, but the actual resistor that you will use in here on the board itself. So the photoresistor, if you think about it, it's the things that we use when you see on the street. You might see a light come on, and that's because of the threshold that is set from the photoresistor, realizing that, hey, it's not outside, let me turn the light on. So, and then when it's light outside, it's like, hey, it's too much light, I'm gonna turn off because everyone can see. So that's what the photoresistor, one of the photoresistors examples would do. And for another project, what we'll do is we'll usually hook it up to a light and actually put our hand over and see the LED turn on. But for this project, we're just gonna run the photoresistor alone, and then we can add the LED to it. So here we have our ground and VCC. Well, our ground and VCC. So we're gonna locate ground and VCC on the board, which is VCC would be 5 volts, then ground, and then the yellow cord would be our analog. And photoresistors are rated analog, not digital. So we're gonna connect to the A0. So because we don't have the light to tell us that it's working, we're going to use the actual code, and we're going to program the code to show on the serial monitor that it is working. So when I upload the code, so once I upload the code, I hit here. I had to ensure that the tools and the port was connected, because this is a Arduino Mega board and not the regular ones we're used to. So actually you can see on the right here, when I put my hand in front of it, when I put my hand in front of the sensor, it means it's getting darker. When it's away, it's a little high, it's a little lower. But when I put my hand in front of it, it's higher, because that's how much dark this is, essentially showing us the dark hue and the analog value that is reading from the photoresistor. So we can also so with that, we can also add a LED to actually show us how the photoresistor is working in real time. So let's connect it. So let's do that. Oh, and then for the code, what the code is, it says serial begin, and then that is for the actual serial monitor, and we're going to set it to 9600, and then the integer value of is analog read, and that's just to show that the photoresistor is analog. And then for the serial print in, it says analog value, and that's going to actually show, like, it's going to print on screen the analog value, and then the value of the what is reading from the photoresistor, which is serial print, and then with delay, and then it'll do it again. So as far as adding the LED, we're going to add the LED on the breadboard, and we're gonna go like that. So let's do that. So what I did is I added my first LED. All right, so here I have the photoresistor circuit with the LED, so we could actually see it turn on and off. All right, so what I did first is, so let me do this. So first step first is your breadboard, and I put the LED on here. So I have my positive leg going towards the resistor and my negative leg just by itself, because I'm going to hook a wire to there. So now I know I need voltage from the circuit. So what I'll do is I'll take the VCC, which is 5 volts, and I'll connect it to my breadboard like this. Then I'll take ground and connect it on the other side as so. And then what I'll do now is I'll connect my components that require VCC and ground. which is the photoresistor for one. And I'm going to connect the photoresistor back to A0 because that's what I set it as in my program, and that's what I was using. So as far as this is how my circuit looks right now. So as far as my LED, I'm going to take a wire from the positive leg and a wire from the negative leg. And I'm going to connect the wire from the resistor to pin 13, and then the wire from the negative leg to ground. So now we have a LED that's lighting up because the threshold is below what we're designating it to. So if I was to make the threshold to say 450, so the way we'll know this threshold is by what we'll see in the serial monitor. So when I pull up the serial monitor, it'll show me the value, and I want my value to be under that so my light can turn on and off. So right now, if I put my hand over the photoresistor, it turns off, right? And then when I put it on, when I remove it, it's on. So it's working. And I had to set my value to 450 because the light in my room is so high that it's reading 200. So at 700, 800, it goes dark, and higher, so lower it goes on. So that's one project we can do with the photoresistor.